going to share.
Sure.
Have a great day, sir.
Yeah. Okay.
Professor Saranya, we can start.
Okay, ma'am. Thank you, ma'am.
Shall I present?
Sir,
Just a bit.
Madam will introduce
Short
you, then after
introduction.
that you can share, sir.
Okay. Okay.
So, blissful morning to everyone. You have done it better and you have do it now. See the positive possibilities. Redirect the substantial energy of your frustration and turn it into positive, effective, and unstoppable determination. With this beautiful and optimistic quote, I'm very happy to welcome you all for the fourth day of online faculty development program on recent trends in 5G communication, design, and technologies. So let's start the day with great energy. I'm extremely honored and happy to welcome the speaker of the day, Mr. Sendal Gurusamy, Senior Technical Specialist, Nokia. Welcome you, sir.
Thank you.
I'm to take privilege to introduce Mr. Sendal Gurusamy. He has completed Bachelor of Engineering in Electronics and Communication Engineering from Government College of Engineering, Tirunelveli in 1999. He has overall 23 years of experience with telecom industry and currently he is working as a senior technical specialist embedded system software in fixed network broadband access group at Nokia. His areas of expertise includes wireless and mobile communication system and networking. Sir has worked in various types of networking devices, protocol stack, embedded software, and he has given many guest lectures and seminars in many industries and in engineering colleges in the area of communication and networking. So, without any further delay, may I now invite Mr. Sendal Gurusamy, Senior Technical Specialist, Nokia, to take over the session and enrich our knowledge in the topic IT Multicast Video Technology. Over to you, sir.
Okay. Thank you, ma'am. Share my screen.
Sir, you can be a little bit louder.
Okay, madam. Is it okay now? Hello.
Yes, sir, it's audible now.
Okay. Okay. Is my screen visible?
Yes, sir, it's visible.
Okay. Okay. Welcome all to this IP Multicast video technology session. So before going into this technology, basically I need to give you some background of this to understand. Because this is, I'm working in this multicast technology for the past 5 years, and it's been widely used across the world, and millions of customers already using these services. But it's yet to be available to Indian market. Okay, it's a technology where it is uses the IP multicast service to deliver the broadcast services to the home. To understand more, it's better we understand or compare this with an existing technology what we currently use. See, currently, if you take our video services, broadcast services, we have something called a cable network, where the cable all over the streets, it will be running and it will come to your home, and there will be a set-top box which will connect this cable, and then it will be connecting into the TV. And this set-top box does the basically what it does is it has an application which will have predefined with a lot of video services with their corresponding signal frequency. So Based on the user selection, it will go and connect to the particular or tune to particular frequency and start getting the streams in that frequency and start decoding and displaying on the screen. So this is the typical video services delivery on a cable network. So same concept for DTH also. In DTH case, the signals will be received from the satellite. Again, it runs through the cable from the satellite dish to the set-top box. And then set-top box does the same thing, tuning to a frequency based on the user. So each channel, each broadcast service will be mapped to a channel, and then each channel will be mapped to a frequency. So when the user selects a particular channel, it will be selecting a particular tuning to a particular frequency and taking the content and then decoding and displaying. Okay. So this is with respect to the traditional way of getting a signal through a cable. Okay. So this same thing. Say nowadays, what happens is the service providers who is providing IP services, where we internet services to the homes, they also want to add a lot of add-on services, or they want to pitch into other domains to deliver the services. Like this technology is used for them to deliver broadcast services to their internet users, without have to have them having a separate cable connection or a separate DTH connection or something. So basically, how it is something like this comes with an set-top box called IP set-top box, internet set-top box. So these set-top boxes will be connecting to the router or the modem, which is supplied by the service provider. So from the modem, it will be connected through the Ethernet to the set-top box, and then the set-top box will receive all the signals as a multicast. So okay, I will go into detail each word. What does it mean actually? So this set-top box will receive that data, and then it will decode the information, and then it will be presenting to the TV as if what the other cable set-top box did. Okay. So that's the background of it. So it is something like the service provider who wants to give an additional broadcast services to their customer, then they will go for this technology and they will use IP set-top boxes to deliver this to their home. Okay. So what is this multicast? It's all about. Okay, first we'll start about IP. So I hope everybody be having aware of this internet protocol, where this is the base of the internet services. So every device in the internet will have a corresponding unique ID, which is called internet protocol address or IP address. So with that IP address, they will be communicating with each other. So this technology is based on that IP, that our ISO OSI model layer technology, where it will be using the IP services or the layer 3 services of ISO OSI model. Okay. So it basically the data will be coming as an internet protocol packets, okay, and then it will be delivered to the set-top box, and then set-top box decode those packets and reassemble the video frames and then deliver to the TV. Okay, so the fundamental base is an IP technology, so that's why it's called IP. Okay, then the next part is called multicast. What is this multicast? Okay, probably I'll go to the next slide. Okay, this is the multicast concept, how it works. Okay, multicast is a group communication where the data transmission is addressed to a group of destination systems simultaneously. Okay, so before going into the multicast, maybe I'll tell there are three terms used in IP communication with respect to how the data is delivered. One is called unicast, and then second one is called multicast, and then third one is called broadcast. So these three different type of delivery mechanisms are used by IP. So the first one is called unicast. As the name mentioned, unique, it means that it will be sent to only one. So it is basically like sending one person to another person. So basically, like in this case, there's a red dot which wants to a device wants to send it to another device which is of green. So what happens is it knows what is its IP address of the green. Okay, so it will be a unique IP address. So as I mentioned earlier, every device on the net has its unique IP address, which will be identified by the other users in the net. So the red dot knows what is the IP address of the green. So how it knows, it's depends on various factors, various things. There are some protocols called DNS, which will be available for the user to convert. Say, for example, if you are trying to connect to Google, the moment you say google.com, then the DNS server, domain name servers, will translate into its corresponding IP address, because IP address is a 4-byte number. People cannot remember a 4-byte number, which is of 32 bits. So to make the life simple, there's a protocol invented called DNS, which is the domain name server. So each name will be mapped to an IP address. So the people will start use instead of numbers, they will start using the names. That DNS will responsible for converting into its corresponding IP address. So in this case, the red dot wants to communicate with the green. So basically, the red will get this green's IP address. So whatever data he wants to send it, that IP information or IP packets, basically IPs will be sent as packets, not in continuous streams. So it will be constructing an IP packet and then putting this green's IP address as a destination address, and then sending it to the green. So this is called unicast. So it is like a one-to-one communication. So the data always reaches green, and then green will read that data, and then in turn green again will send an, if it wants to have a communication with red, it will use the red's IP address as a destination, and then sending back the data to the red. This is called a unicast service. Okay, so it will be directly communicating with each other. Okay, so the intermediate devices here, this point where we call it as routers and switches in the internet. So these routers and switches are the backbone of the internet, where they will be forming a mesh kind of network, and they will be routing the data between the end host systems. So here the red and green are end host systems where they want to communicate with each other. So the turn, which is basically like an intermediate router, which will be doing this translation and sending to the green. So the routers and switches on the internet will know where each guy is residing, where this red is residing, where this green is residing. So there is something called an routing protocol or routing stacks, which will be help them to distribute that information. So they will have routing tables, which will say where this green is available, irrespective of where the data is coming from. So they are responsible for this routing. All the network is built on this routers and switches. Okay, so when that red data sends to the router, the nearby router, the nearby router will find another router. Those things are like, we'll not be going into the detail. So basically, the red will give it to the router will know where to send green, so it will directly send to the green. So this is all about unicast service. Okay. Whereas if you come to multicast, multi means the term itself means that it is too many. Okay, so there is one more called broadcast. I will go to that next. Okay, so multi means many. What does it mean is here there is one red guy who wants to send data to all the guys who are in green. Okay, so what does it mean is all these guys will have an interested in a particular information or a particular data. Okay, but they each one has its own IP address, right? So what happens is then the red has to send 3 different data. Say, for example, if all the 3 greens want to receive a particular information from red, but it is a common information, which is there is no specific to each green. It is a general information. Then if the red has to use the unicast protocol, then he has to send 3 data to all the 3, because he has to find out what is this first green IP. Then he has to send it to first green. Then he has to find it out second and third, like something like that. So this is actually a overhead. For example, if you are sharing a common information to the all these 3 greens, okay, there this multicast comes. What does it mean is this multicast, then there is this unicast address, we cannot use it because those unicast addresses are unicast to those individual nodes. So then there is a mechanism required. So what does it mean is it's a multicast service, where what each there is a set of IP addresses defined by the IETF standard, where the Internet Engineering Task Force has come up with a list of IP addresses which are called as multicast IP addresses. Okay, so that means that those addresses will not be assigned to any particular node, but any node which want to receive a data on a particular multicast, those nodes can request those data. Okay, then the intermediate routers, the routers which are intermediate, should handle that information. So in this case, what happens is this red wants to send a data to all the three greens. Maybe I'll go in detail in subsequent slides how this whole thing is working, how the multicast communication is working. Okay, probably for introduction things. So the red will send a data which is common for all the three greens. It will reach this intermediate router. That the router knows that there are three guys who needs this data. So this router will replicate that data and send it on to each guy. Okay. So the thing is, like, now the red doesn't need to send this data to all the three. The load on the red comes down, and this guy who is intermediate is doing this replication work. Just replicates the data and send it to all the three greens. Okay, this is called multicast. So the multicast is used to widely used for video services, because when you say video services, the content is common. It is not specific user. It's a common content which has been viewed by many people. So the content is common. So you no need to replicate the content at the source itself. So it will be given to the network routers and switches. Those switches and routers will responsible for replicating this information based on it. See, in this case, in this router has three other nodes, but these three nodes doesn't no need to receive the data because they are not interested in. So this router will aware that only these three nodes are interested. So he will send only to these three nodes. Okay. So then the third is called broadcast. Broadcast is something like everybody will be getting it in that domain. So the broadcast is actually a domain specific. It will not be universe. You cannot send a broadcast to everywhere in everything. It is something like an broadcast domain. So there is something called VLAN domain or virtual LAN domain. So they'll create a broadcast domain, and then in that broadcast domain, if one guy wants to send a data to everybody, then he will use that information to broadcast everybody. Say, for example, in this case, assume all these three, red, yellow, and green, are in same broadcast domain. What happens is this guy who is red, who is say wants to tell that I am available to everyone. I am just newly come to this network, and this is my IP address, something he wants to advertise. Then he will use something called a broadcast. Broadcast, again, it's an address which is defined to use by everybody. Okay, it's not like a unicast means only to particular node, and whereas multicast means a group of people, but broadcast means it will be to everybody. So if this red is sending a data to everybody, then it is called a broadcast. So the address, the destination address which is used in that packet will be a broadcast address as defined by the ETF. So once the intermediate router receives that packet and understands that it's a broadcast packet, these routers will, irrespective of what this guy will do, the intermediate router will be flooding, it will be sending to every node he knows or every link he knows. So the data will be sent all the nodes. So all the nodes will be receiving that data. That is something called broadcast. Okay. So each one has a purpose. So unicast means its purpose to do one-to-one communication between only the two nodes, whereas this multicast means a group of nodes, and then broadcast means it's to the entire network or the broadcast domain. Okay. So this is the basic point of the multicast. So this is the multicast technology which is used to deliver the video services. Okay. Okay. So then it comes to multicast and unicast. What is the difference? Okay. So now also in India or in other places, we have something called you can compare it, like we have an applications which they say that you install this application in a smart TV, you can get all the broadcast services. Okay, those applications are something like a unicast applications. Okay, You take an Amazon Prime or a Netflix or or any other services, those are called Unica services. What does it mean is like you will be connecting directly with an connection with the server. Who say, for example, if you are using an Amazon Prime, then you are connecting to Amazon video server. Then there will be a dedicated connection will be established between you and the Amazon service. Even in case if you take a live channel on YouTube, okay. So the YouTube live channel, every whoever comes in will be connected to the YouTube service, and then YouTube server will be giving an data to each of the who connects to joins to that particular YouTube channel. Okay, even though it is a live, everybody will be getting a copy. Okay, that is what the Unica service. So it is like to a single recipient. So each recipient needs a separate connection to get the data. Whereas in multicast, it's a group recipient. So it will be like a group of people who will be interested in a particular channel. Then all of them will be getting it. Okay. So the only difference, the second difference is like Unica services, no special network devices needed in between, because the devices in between has a normal routing mechanism where based on the destination it will be doing the routing. Whereas the in case of multicast services, the routers switches who are in between the network who are delivering the data to the end user has to be aware of this multicast service awareness. Basically, he has to understand what is his destination IP, what is whether it is a multicast IP, who are all listening to, where and all I have to replicate the data. So that awareness is needed. But nowadays, if you take any routers or switches on the internet, most of them are aware of this multicast services. But thing is that if you are buying a product or any network device which needs a multicast awareness, then there will be extra cost involved. So that is it will be a kind of special device is called. And so again, when I mentioned in the earlier, so if it will be multiple copies from the server. So for example, if there is a YouTube live channel is happening, there are thousands of people are connecting to that server, then the server has to do copying of the data. That's why they'll be having a big servers with all load balancing to handle thousands of their end user to serve them when there is a live program going on. Okay, so the server has to be heavily loaded at that time, and he has to do a lot of copy generation and then sending to the user. Whereas in multicast, it will be a single copy from the server. The guys who are intermediate routers and switches will do the replication, will do on behalf of the server, will do the replication based on the need. Basically, I will explain how this replication happens in the subsequent slides. Okay. So this is the difference between main differences. Here, the multiple copies of the same data sent to each user. Here, the single data will be sent from the server to the all user. So the basically like this has a scaling impact. Say for example, if you are increasing your customer base, you are doing a live program, you will have like 10,000 to 50,000 people will be joining. Then there will be a huge bandwidth needed for the server to serve all those 50,000 people. So he may need multiple load balancing servers to handle all those data. Whereas in case of multicast, no scaling at the server, whether you are 10,000 clients or 50,000 clients doesn't matter, because it's going to send only a single data to the network. Okay, so there is no impact on the scaling when you go for the multicast service. These are some of the points where they prefer to go for the multicast service when you go for an video services to the end user. Okay, so maybe I will go to the next one where I will be explaining how the whole thing is working. Okay, IP multicast is a bandwidth conserving technology. Why it is called conserving? Maybe when I explain the flow, you will understand it. That reduces the traffic by simultaneously delivering a single stream of information to thousands of recipients. Say as here it is something like say there is a video server which is broadcasting a video service. There are intermediate routers in the network. Okay, so how the network is formed, and there are three receivers, multicast receivers, who interested in receiving this data. Okay, so how this happens is, so here how things works is, the source is sending a single data. So he doesn't bother about whether the 3 clients, 4 clients, 10,000 clients. He just send a single data to the next router in his uh, uh, base or in his path to the reaching the nodes. So the multicast packet is what happens is the router, when the moment is receives this multicast packets, it's replicated here. So he will replicate to both routers, and then when the second router comes, he will again do a replication, and then it will this end router will give it to the source, then the source will receive it. Okay, maybe I'll give an example how these things works with this is the comparison between if somebody is want to use unicast service and somebody is want to use multicast service, how the whole network looks like. So for example, in this case, there is a source and 3 nodes. Okay, there are 3 nodes are unicast services. They want to receive unicast services. So what happens is this source has to send 3 data to 3 different users. The first data goes via this router to reach it. So basically, it's a unicast services. Those routers, intermediate routers, knows where to send it. So this router knows it has to, for source A or the first source, it has to send it to this router. So it will reach here. From here, it will reach here. So the thing is, like there are 3 data comes from this. Say assume that each one is watching a channel. You assume a normal SD service, not an high definition service. It will be like a 1.5 Mbps data, which is a normal video service for an to view an SD channel. Okay, so there's a 1.5 Mbps data coming from all these 3 routers to all these 3 users. Okay, whereas to receive this 1.5 Mbps, this router has to so it is something like when you go back here, so it is this router has to sending 1.5 this side and 1.5 this side. So that means this router has to now handle 3 Mbps. So it has to receive 1.5 Mbps, and then it is distributing to 2 users like 1.5 this way and 1.5 this way. And similarly, when I go back to this node where it will be receiving 4.5 Mbps here. So 3 Mbps is transferring this side and to 1.5 Mbps here. So this is just for 3 users. So assume that if there are thousands of users, then what will happen? So the server will be loaded with the pipe will be with more bandwidth to be reserved in the server to handle all those users. So to address that, they'll go for a they'll go for an load balancing servers. But again, it is something like the server has to be big enough to handle, even if it is a 10,000, maybe each server is handling 1,000 or 2,000 users, then it needs that much bandwidth to handle it. Okay. Whereas if you take multicast service, it will always 1.5, irrespective of number of users connected, because each node in this network is replicating the data. See, this node replicates to this two, this replicates. So the end user, all of them will be receiving the same data and it will be replicated everywhere. So the server is not loaded. Only the guys in his network is he is doing a replication work, but still actually comparing to this bandwidth usage, this is actually 1.5 Mbps only. It's overall. Only the guy has to do replication of the data, whereas here he has to handle the higher bandwidth data. Okay. So this way, this has a more advantage, or it is like the network will be more stable and not be congestion. The data delivery will be more trusted or not trusted. It is more reliable than compared to unicast services. Okay. This way, this how the multicast scaling is impacting or unicast scaling is impacting when why we going for this multicast service. Okay. Coming to the next one. So here that multicast packet is replicated. So every node level it is replicated. That's what it means. So okay. So as I said, each unicast, multicast, there are address ranges defined by IETF. So first they define actually there are 5 classes of IP addresses defined by IETF. One is class A, B, C. Class A, B, C are called unicast services, and then class D is called multicast. So they have reserved a range of IP addresses. These are the range of IP addresses meaning that these are not destined to any node, but it is destined to a group of people. That is the meaning of this address range. So if you are running a multicast service, if you want to send a multicast data, you are supposed to use any one of the address from this range, so that the routers, intermediate routers, we know that it is a multicast, and based on the need, it will do the replication. How he knows it, I will explain later when how the mechanism, whole IGMP mechanism is works. Okay. So this is called class D, and one more is called class E, which is an reserved and not used for its special purpose. We are not talking about that. Okay. So basically, multicast means it's a class D service. So class D address range will be used as a multicast address. Okay. Okay, so when you compare an IPTV service with multicast versus unicast, multicast means which uses IP set-top box, whereas unicast means what you have an app in your TV to deliver an IP, which receives an multicast when you receive a video service. Okay, so if you take a multicast, it is actually a local, so it is not a global. Basically, like if you are want to do a multicast service, it is it's a closed network where because it will not be everywhere internet, only selected routers will be supporting. So it will be like a local. Local means it is something like a service provider network. So basically the service provider will enable multicast in his network, and then he will serve it. So basically, like if you are taking any service provider of internet provider, if he has, only he can provide that IP service. He can provide the multicast service because he knows how to do this routing with their routing protocols. So he will handle it. Whereas unicast service is global, meaning that irrespective of your internet service provider, you have an Amazon app or an YouTube, you can connect to YouTube channel from anywhere. So it is called global. So it is not service provider dependent, whereas the multicast is service provider dependent. So the delivery mechanism. So the delivery mechanism is premium in case of multicast because each node in that multicast network routers, they will reserve some bandwidth for these multicast services. So those will be reserved always, and they will not be they will not be disturbed by the spike coming on the unicast network. So it will not be impacted when they're delivering the IP multicast IP set-top box with IP multicast service to the user. Okay. Whereas unicast service is global, where it will be delivery is general. Basically, it is not a reserved bandwidth or something. So your YouTube channel, maybe if sometimes you will get it as high definition, sometimes you will see that there will be a degrade in video quality. That's all because of its services comes through and not a premium. It is an general delivery mechanism. So there won't be any guarantee that you will get always the standard guaranteed bandwidth for an unicast service. That's why when you're watching a high definition service through all these apps, sometimes you will say that it will switch to the normal mode, not from the high definition mode. That because of this delivery problem at that time. Okay, so it is basically a general delivery mechanism in general. It is not a premium. Okay, and both has subscription based. Whether you are using an unicast IP service or a multicast IP service, both are subscription. So you subscribe for a particular channel, then you'll be delivering that channel. Okay, it's all both are subscription model. The size of the ecosystem. So the size of ecosystem is small because it is being within the ISP network or the service provider network. So only his users will be able to use his services. Somebody from other service providers, only he can use when the service provider provides this service. So it is within the ecosystem and it will be small. So if the service provider has a number of users, only he can get only a number of things. He cannot increase its IPTV services beyond his subscription account. Say, for example, a server had 10,000 users. Only those 10,000 users can use IPTV. He cannot go beyond that. Okay. Whereas in case of unicast services, it's big because the market is big, ecosystem is big. Anybody can, anybody on the internet can use that app and servers to connect it. So it's very big. Okay. Expansion cost, it's very low because it's within the network. So they will not be having much overhead to handle this. Whereas if you go to Unicast, it's very high because when you want to support 50,000 to like 1 lakh user, they have to replicate their servers with a large load balancing mechanism, which is more costlier and which needs more cloud and infrastructure at the server side. Okay, so these are the comparison between how between what is IPTV unicast and IPTV multicast service. Why people used to, so based on the need you will select. So for example, if you want to give your IPTV service to everybody and not restricted to your particular ISP, then you go for this unicast service where it's all based on the app application where it will be end-to-end connected. Whereas if you are within an internet service provider network and you want to do an IPTV service, then this multicast is the option. Go with an IP set-top box to deliver this. Okay. So based on the need and the things, you can select it, which service you wanted. Okay, so when you come to IPTV network elements, there are 4 elements in this IPTV end-to-end service. One is called head-end. The head-end is something, it is where you get all the data from all the broadcast owners. Say there are whoever is doing, this is something like it will collide all the data which is coming from different broadcast owners, and then getting it into a channel. It will map into a channel and then creating a IP network where it will be it will do all this combining the broadcast information. So that is called head-end. And then second is a transport network where this information will be transported inside the ISP network. Maybe I'll subsequent slides I will explain how the whole thing will work based on a typical topology, which I referenced India so that people will understand. So how the transport network is formed. Then the third is how the access network is formed, how the access network works on this delivering this IPTV service in this multicast network. And then last one is how the home network finally works with this IPTV network. Okay. So these are the 4 elements of IPTV. So coming to, okay, this is the end-to-end service of an IPTV service. Okay, so there are various elements in this thing. This is first thing is you receive the content providers. So the content providers are the broadcasters. From the broadcaster, the head-end will receive the data either through satellite or some other means. So it will receive the information and it will come to the back office, which we call it as head-end, where you will do all these conversions. Okay. So this is the receiver whose content from the broadcast company will be received on this, and then it will comes to here where you will convert the video stream into multicast packet and forward to the core network. So this head-end will do the allocation. So it is basically like a reserve each broadcast or each content to a particular. It will first do the encoding of the messages to a particular encoding type. Either it will be MPEG or an H264, depends on the content. If it is a huge content, they go for H264. If it is a normal SD content, they go for a simple MPEG encoding. So once it is encoded, again, they will use an encryption mechanism, but I will not be going into the conditional access system because it's altogether another big session. So basically, they will encrypt the data so that the data content will not be viewed by anybody. Only the the subscriber who can receive and can get the content. So to do that, they will encrypt the content. So all this happens in the header. Okay. So then once it is content is encrypted, then that will be converted into an IP multicast packets. So basically, they will be reserving some multicast addresses. And then those addresses, where each channel will be mapped to one multicast address. And then those channel streams which are converted into packets or IP packets will be put with that multicast address and send it to the backbone IP network. Okay, so this backbone IP network will be aware of this multicast IPs. So they will do the multicast routing inside their network. And then finally, these networks will deliver to the end device. Okay, so end device, again, it can be a cable device. Basically, it's a cable access point, or it can be a fiber access point. Okay, so either it will be a cable or it will be a fiber. Okay, so these two guys will be receiving all the multicast data, and then it will be pushing these data to the user. Okay, so the cable network is, it will be sent it through the cable. Okay, so it will reach the cable guy, and then it will reach the set-top box, and then it will go to the TV. Whereas in case of fiber network, it will go through the FTTH, the fiber to the home network, basically the optical fiber. So this is called OLT, which is called optical line termination, where it will terminate all the optical lines of the user. So basically, it transmits to the optical line to the end user. So once it goes to that, it will reach an something called ONU, or the optical network device, where it will terminate the optical service, and then it will be either be a modem, or it will be a home router, where it will be giving a data to the home network. So then each will be having IP setup box to receive that multicast services, and then it will do the descrambling and then decoding and then giving to the TV for the end user. So this is the end-to-end delivery. Yeah, this is the routers that will receive the forward the multicast packet to the core network, and then it will reach finally to the end device. So this is called access device. So this is the core, this is the head end, and this is the access, and this is the home network. Okay, so this access device will receive those data and then forward to the home device. So in the home device, you will receive those packets. Basically, that setup box will receive that data, decodes it, and then streaming the data to the TV. So then the TV will be streaming the viewing, user will be viewing the data in that network. Okay. So this is the end-to-end flow where you will start from the head end to the core network, access network, and then home network. Okay. So that typically this is the flow. Okay. So there are two standards. One is called DOCSIS standard, where it will be used on the cable network. Another one is called GPON standard. Okay, this is used in the fiber network. Okay, so this I said this OLT, right? So I am working with Nokia for the past 7 years in this technology, and mainly I'm working on this device. Okay, this is called an optical line termination device. Okay, this will be there in every central office, where you are. This is actually this is same as the old mechanism, where they have a DSL modem which is coming and connecting to the end user. So same way it will be called as OLT in the optical network, where this is called an OLT, optical line termination. So this is called the optical device. What this is, these are all called line cards. Okay, these are all called line cards, and each one is an user interface. So from here, there will be each one will go in an optical line. Okay, to the end user. So it will go to an optical line. Either it will be directly reaching a home, or it can be another device. They'll call it as mini OLT. This will go and connect to a mini OLT. That mini OLT will be connecting to individual homes. This mini OLT, generally you can see if you are in a multi-storage apartment or something, in the basement you can see that mini OLT. That mini OLT will be connecting all the end user through fiber. That will aggregate the data, and then that data will come to this central office OLT. This central office OLT will be somewhere in your area, or in case of, for example, DSL network, you can see them in the telephone exchanges. Okay, so this will have the all the data will be coming and connecting. So this is, each one is called an line termination. So this is actually a 16 FX16 card, where you'll see the 16 line cards, and each line card will have 8 interfaces. Okay, so it's like a 8 fiber connection going out of this. Okay, then intermediately in the middle, you can see these two are called network cards. So the network card purpose is to aggregate all this line termination data to here. So this guy will do the aggregation, and then it will from here it will go to the subsequent area. Basically, it will go to the router or the next switches, like where I said, right. So here it will be terminating, and then it will take it to the broadband backbone network. So this guy will be responsible for aggregating all those data and then sending to the backbone network. Okay, and this typically will have a redundancy mechanism, where they'll be having 2 network cards. Okay, so the idea of this redundancy is to provide a service. Even the one card goes faulty, or if there is a software fault in one card, the other card will take over and then have a service. Because say, for example, if there is any fault in any of this LT card, only those users will get impacted. Whereas if anything goes on this backbone card, the entire service all those will get impacted. To avoid that, there is a redundancy mechanism built on this card and this OLT that is called redundancy, anti-redundancy, where there will be two network cards. This both network cards will be connected to the same core network, okay, and two different backbone routers. So one card goes, the other card will take over, so that there won't be any disturbance on your services. Say this is the way. Say for example, there is any one card fails, only that user will get impacted. But in this case, if you don't have this redundancy, the whole area will get impacted. So to avoid that, there is an redundancy built on this. So these OLTs have all these services. One is called that is what I said, my IPTV services or the multicast services, and it supports all high-speed multi-video data transmission, and it also supports high-speed internet services. And this has a lot of provision to make some business access. So you create some users as business users, so those will be connected with, you have a bandwidth reservation. So some cards will have, if say for example, I am connecting this first line to a business user, then what I will do is I will actually do a reservation for that user. Data coming on that user will be a reserved bandwidth, so the data coming from that user will not be impacted when there is a network congestion on this network. Okay, so the data on this user will be directly taken to the broadband network without a backbone network, without impacting others things. So that is a that kind of configurations also these OLTs will be supporting. That is called business access. And then this also supports cell site backhaul. What is that cell site backhaul? Is basically this can be connected to a tower, which is your 4G or 5G towers. So the data which is received from your mobile network to the tower will be again landing on this OLT. So that your tower will again in backend, it will use the fiber to reach this guy, and then using this guy will have an cell site backhaul configuration. Using that, it will take the data to the corresponding service providers network. Okay, same way for voice also. So voice also, what will happen, these guys will have an PSTN connection services, where it will be all the voices from the 4G or 5G will be converted into basically like the 4G and 5G actually doesn't use an circuit switching. It actually uses a data switching, where everything will be in the mobile phone itself will be converted into IP packets and then send it to the server. So this 5Gs and 4Gs data will be reaching here. So this will be those data will be segregated, and then it will be sent to the PSTN gateway through which it will reach the telephone network. So it does that also. So it is kind of a one device having multiple functionalities to achieve various need on the customer things. Okay, so that's this is the thing I'm working on the past 7 years to delivering it. Okay, so all these services. Okay, so I'll explain this IP technology. I told this all the four elements of this, right? The head end, and then transport network, then an access network, and home. So all these things I will explain with this slide. Okay, so basically, like here, say I just put in a service provider network. So assume there is a service provider who has a network across India. He has his network in Delhi, Calcutta, Chennai, and Bombay. Okay, so he will have his main gateways in those cities. Okay, so all of them will be interconnected. Okay, through its high-speed back-end fiber network. Okay, and assume that this Delhi has its head-end service. So what this head-end service will do now, it will receive the broadcast from the content providers and then convert them into an IP multicast packets. Okay, and then this head-end will be giving all the data to this Delhi, which is main server. Okay, say for example, somebody is here in Chennai. Okay, Chennai again. You come here, Chennai. We have, say for example, area-wise. There will be like someone in something in central where it will be a main server, and one maybe something in T Nagar, which is in another place where we have main server, and something you say somewhere in a remote like Tambaram or something where there is another gateway. So all these not servers, sorry, gateways. So all these gateways may be connected like this. So there will be a central server in Chennai which will be connected through different gateways to this Tambaram gateway, and then there are users in Tambaram. So assume that there are 3 users in Tambaram who are subscribed for this IPTV services and who has IP set-top box in their homes. Okay. So now say that, for example, okay, this is the headband, this is the transport, this is the access, this is the home. Okay. Okay, so I will explain overall flow, how the data flows, the subsequent slides. I have to speed up, I think. Okay. So this is again comes to the network. So there are multiple multicast protocols involved in this. Okay, so basically there are two mainly. One is called IGMP, so Internet Gateway Messaging Protocol. So this is used in the between the home and the access. This protocol will be used to communicate. What is to be communicated is basically like if you are interested in multicast, but you have to subscribe for that multicast service. Then only you will be getting that data. To do that, there is a mechanism needed, right? So that is defined by IETF called IGMP, Internet Gateway Messaging Protocol, which will be used to get access between these two. Once it is reached in the access network, then there is something called a protocol independent multicast, where it will be run in the backbone network routers to exchange the multicast routing information. Like unicast, this multicast information also to be exchanged, like because unicast mostly it will be an static, whereas in multicast it is basically a dynamic. So you say for example somebody is from Chennai is interested in some particular channel, then that information goes to all the way to the backbone, and the backbone this PIM protocol independent multicast, which is again another standard which is defined by the IETF, which is used to inform about this all these backbone routers to say there are someone who is interested in getting this particular channel, something like that, or this particular multicast service. So these two are these two multicast protocols which are responsible to deliver the multicast service and end to end, so that you will have this IPTV services delivered to the home. Okay, so coming to the home user. So I said it is an IGMP. So how the IGMP works? Okay, so basically it is something like your TV or your set-top box want to receive a particular channel. Okay, so what happens is this set-top box or your app in your TV. Basically, it's a set-top box which has an app in it. That app is just predefined with what is each channel belongs to, what multicast IP address. Okay, so each channel will have a corresponding IP address, which is a multicast IP address, which is mentioned in that where it has been already programmed in the set-top box. IP set-top box, so it has been downloaded in the software, which will have this what is the IP address or multicast IP address for a particular channel. Say so when a user turn to a particular channel A, then what this set-top box is sending an IGMP joins. Basically, it says that I am interested in particular multicast group or the channel. So you just assume that this is something like what you have in traditional. In your traditional, you have a tuner with a particular frequency, right? So the set-top box knows that if I want to go to a channel A, he knows what frequency it has to tune. Similarly, here the set-top box knows that if the user has to view channel A, what IP multicast service I need to request it. So that when the user is requesting a channel A, then he converts that channel information to an IP multicast, what is IP address, multicast address, and then he generates a join message saying that I am interested in this multicast. So he'll generate an IGMP joins and send it to the nearby router. Basically, it comes to the OLT. Okay. Now, OLT in turn will do inform this to the core network through PIM protocol, which is again a complicated one. We will not go into that. So the PIM protocol will take care of getting that information. So now what happens is this guy now receives the data for the channel E. So now this guy has the channel. Oh, so he will give that channel to the TV. So he will deliver that multicast service through this IP set-top box to the TV. So the set-top box will receive the data, decode it, and show it on the TV. So he will say that, okay, so every time when there is a channel, he will send that I am interested in this group, then he will send the data. Okay. So now the question is, so he will be keep on sending, right, this data to the thing. So for sometimes, say, for example, he has switched off the TV, or is it he's switching back to some other channel, then this packet to be it need not be required for this guy to receive, right? So To do that, what is the mechanism is this OLTs will that IGMP gateways will be sending an IGMP query. Every 120 second, it will be sending an query saying that, are you still watching this channel? Are you still watching this channel? Are you still interested in this? Then the set-top box will send an join. Oh yes. So that is something called this guy will sending a query on every. So apart from this sending the data, you'll be sending this query on every 120 second, asking whether you are still watching this channel. Then this guy will say that yes, I am still. If still watching, he'll say that I am watching. If not, he will not be sending this join again. Then this guy will stop this. So he'll stop this sending this data to this message. Sometimes what happens is this is the case where this joins will be used to whether he knows. But if a user is properly moving it from one channel to, say, for example, he is moving away from channel A to channel B, okay, then what happens is the set-top box itself will send an event called leave me from this group, okay. That's something, then he will stop sending it. So this is the graceful way. When you move from one channel to other channel, the set-top box will say that, okay, I don't no need this channel anymore, leave me from this channel. Then the gateway, which is the OLT, which will stop forwarding that multicast service. Okay, now come to this overall network where I will explain how these end-to-end things happening. See, for example, there are two channels which is in this header supports it, like channel A and channel B. The channel A is mapped to a particular multicast IP, and then channel B is mapped to another multicast IP. So these two multicast IPs, basically this information will be there in the set-top box. Software knows that what is this each channel, what is its IP address. So say, for example, in home, first home, somebody is interested in to watch a particular channel, say, for example, channel A. So what happened? He sends an IGMP join, which is channel A. He is interested in channel A. So he's sending an IGMP join with this multicast IP to the nearby OLT. Okay, this OLT then will send an join to another upper node in the access network. So this there are two nodes. It can reach the Chennai central server through two different road. Based on the load balancing, is selecting one of the node, and it is giving a join to this guy. And then this guy will be giving to the central node, which is there in the central of Chennai, where it will receive these joins. Okay, now this guy will be sending a PIM join. Basically, like this is an IGMP join. At this point, this guy will be terminating the IGMP joins and then giving to the PIM join. Okay. Then why they are using PIM is more of a protocol where they will be forming a routing table. Whereas here there is no complex things involved, only this join, leave. So there will be no complex things. Whereas here there will be a network congestion to that. There may be a network restructuring happen. So to handle all of them, there is a protocol defined for PIM. So those PIM will be running inside this core network. So this central server in Chennai will be sending a PIM join to the network. Okay. Now this join will be received on the head end, which is there in Delhi. So the Delhi is already receiving the messages, multicast packet for channel A from his head end. So this now he is received the packet, and so the Delhi server will give it to the Chennai server, and then Chennai server will be giving to its access network. So then the access network give it to this guy, the net OLT which is there in that local area. Then the OLT will be giving to the home. So now this the home which is requesting for channel A will be getting it, and then it will start viewing it. So these all of them will happen actually in within seconds. The whole process will happen within a second. That's for this one. They'll expect things to happen in milliseconds. Basically, we will say typically customer when asked what is your IGMP conversion, we'll say that 10 millisecond, 15 millisecond. Okay, those are the information which will tell that what will be the time taken to get an IGMP to converge to get it data. Okay. There are other factors also, but typically we will say when you have my device, this will be the latency, this will be the time taken to receive an IGMP join, something like that. Okay, so everything will happen in within a second, and the home will get this one. Say for example, now the another home which is there in the same area. So now interested in this channel E, then he just sends a join. But now what happens is this data for channel A is already reaching till this point. Okay, so he already requested, he already getting this channel. So this OLT, which is multicast aware, now knows that then another home is also requesting the data. So you just simply replicate the data and send it to this. That's why I said it's replication. There is the request terminates, the IGMP request terminates here because there is already an IGMP channel form. So this guy just replicates the data and give it to this guy. So now the data is replicated in both the homes, and both the homes will be receiving the data immediately. So this second home actually receives the data immediately. That's why when somebody is moved to a new channel which nobody is watching, he may see in a second to get the data appear. But if that channel is already viewed by many people, then he will see it immediately without any delay, because it all comes from the local node immediately. That's the delivery happens from the local node itself. Where so the thing is. So irrespective of number of users, this way I said, irrespective of number of users watching this channel, the data from the head end comes with a single packet to Chennai, and then the single data to the network area, and then the area level it will be replicated. So that's why there is no network overload when you use this IP multicast services, when we get the data till the home. Okay, this is another part where I'm explaining, okay, another head end where, say, for example, the first head end is supposed to do for channel A and B. Okay, now there is another head end which is there in Bombay, which is responsible for C and D. Okay, then his head end will be connected to his Bombay central server, not server, router, where he will have all those data to, say, in this case, say, for example, the home here in again in the same Tambaram area, the home which is interested in channel C, which is coming from Bombay. Basically, it is resident in the head end where it is getting the channel C from this and then injecting to this network. So now he is getting a join. The joins for channel C is requested. Same way, this guy is now sending a channel C request to the access node, then reaches this guy. Now through this PIM network, he knows that channel C is available via this guy through Bombay router, not through Delhi router. So now he'll send this PIM request for this channel join to this Bombay router. So now that the Bombay router will get the data from the head end, and then it will be delivering the data to the Chennai. Now the Chennai will move data to the access node. Then it finally comes to the home. Okay, so now this home is getting a data from all the way to here. Say, for example, now this intermediate home is watching a channel C. Now the home 1, which is actually watching a channel A, if he actually switches to channel C, he will get immediately. There's a red data will be replicated immediately to him, and then he will be getting the data. But still the channel and this home is still watching a channel A. He will still continues to get this data, because this guy will be querying every this guy will be querying this home as well as this home every 120 seconds to make sure he's still watching the channel. Okay, so this, even though the first guy is leaves, this guy is still watching it, because when he queries, this guy will say that I'm still using it. So the data will green, and the channel A is still given to this guy. And this guy can now switch to C, then he will be replicated the red data to this first guy. So this way, the whole network operates, and then how the whole data replication is happening at the end node instead of at every node. Okay. So this is about how different head ends and then how all the network works. So basically, like how this is about how the PIM routing happens. So, like for example, due to this is what the channel A PIM writes the PIM request for channel A, and then channel A data is coming green, and this is going on. Okay, so assume that there is a fiber cut between these two. Okay, between Delhi and the Chennai, there is a fiber cut. So then whole thing is gone. Now, what this PIM responsibility is, he has to find the alternate route. So what happens is, now he is finding it. There is an alternate to reach this Delhi is via the either through Bombay or through Calcutta. So what happens is, based on the routing calculation, based on the cost, and based on the congestion at that moment, he will decide that through Calicut I can reach Calcutta, I can reach this Delhi. So he will send a PIM join to the Calcutta gateway, then the Calcutta gateway gives to Delhi. Now the Delhi routes this channel data to this, via this it will reach the
Delhi server. This way, the PIM will take care of rerouting the network when there is a network congestion or there is a network drop or a network problem. It will handle automatically. Whereas IGMP doesn't aware of all those things. It will just know the joins and leaves. So that's why they keep this IGMP at the no access level and keep this PIM as the node level or the core network backbone level. Okay, there is something called reverse path forwarding. It is also a part of PIM feature. PIM, what is that reverse path forwarding? I'll now ignore all this access point. I'll keep only the core part and then explain how this things happening. Say, for example, now I send a join, PIM join to this. I'm getting a data, okay, from this Delhi, okay. But for some reason, this guy, even I'm not sending a bin join, but this guy is he is actually requesting for his nodes, okay, and he is also getting a data. For some reason, he's started due to some problem. He's started sending this data. Then the same data will be coming both the to the Chennai things. Okay, so now there will be two data. So there will be duplicate data. This will again increase the congestion in network because two information of the same information will go to the access, will reach the home, which is unnecessary, right? So to avoid that, what happens is this PIM has something called RBF. What does it mean is this PIM will allow only data, multicast data, which is where he requested. So now in this case, he requested Delhi servers to send an channel A data. So what will happen is he will put a rule, right? I will accept this IP multicast only it is coming from Delhi because I requested Delhi. So it will expect only the data from Delhi. If something coming from Calcutta or Bombay, that will be deleted because that will be blocked because the PIN says that I am requesting this from Delhi, so I will receive only from Delhi. If I receive this is from something that is something like a duplicate data, so I am not interested in, I will drop it. So because it will create duplicate data to my access network, so you will block it. So this is called a reverse path. So I will check my path, and then based on my path, I will decide my forwarding decision. So this is called reverse path forwarding, which is used in the PIM protocol to handle the networks. That's why they have two different protocols where different purposes. Okay. Okay, this is we are coming to the end of the session where I'll be explaining what is the trend we are getting in IPTV market. Okay, so this is the trend which I have collected from the public domain when they say how the IPTV network is growing. Basically, it is keep moving. This pink color, which is dark pink color, is IPTV. And then the blue color is traditional cable service, and then this yellow is a DTH service. And then there is called a pay TTH, which is a paper service, okay, pay TV services. So what is this perception is like it is it's keep increasing, okay, where you see that there is an increase in this and there is a decrease in cable and traditional DTH. So because why this is increasing? Because nowadays we have fiber everywhere, and then the service providers of internet provider itself has started providing this. This is there in many countries. I hope it will soon come to India also, these services. So where you no need to depend on a third party or a cable service provider to give your broadcast services. Your internet service provider itself can give you an IPTV services using just an IPTV what is called IP setup box. Using that, you will be along with your thing. You will also get that thing. Now, I think many service providers started giving VoIP phones where you connect your Wi-Fi phone to your modem, and then you will be connected with the landline numbers. So you will be getting a landline number, and then you will be using that. You will be using a VoIP number. Basically, it's a VoIP service which is through internet. You will be getting your landline service. Similar to that, you will soon will be getting your IPTV services also through your modem or router. Okay, through IP setup box. Okay, this comes to an end of my presentation. So it's again there are 20 more minutes. I'll speed up with the last because I want to give any questions or anything I can answer it. So I'm stopping my screen sharing. Okay.
Participants, you can share your queries.
Good morning, sir. It was a very nice presentation.
Thank you.
I'm Dr. Suganti
Thank you, ma'am.
from Rajlakshmi Engineering College. And my question is, what will be the cost factor in this IPTV, and whether it will be, possible for all the people to connect to the internet and view the TV?
Yes, ma'am. Because it now you know that every service provider is a high bandwidth fiber backend. So already you know that in India, people Airtel like that, they are, when you buy a broadband service or a fiber service from them, they'll give a voice phone with add-on service where it will be a free for you, right? So because for them it is something like an add-on service to them. Okay. Similarly, they will start soon. They will start this IPTV service where, because as I explained, like it is not going to affect his bandwidth because it is going to be a single for every channel will be only one multicast packet, not a many. So if even your number of users increases, his bandwidth is not going to impact anymore because it's going to be single data for every channel, right? So it will be mostly it will be a free for you initially. Even in long term, he will provide a add-on service, free service to make people to that use his services for IPTV. Only thing is, maybe if you are going for a premium channel, where maybe you need to do some subscription, whereas for all the free channels will be getting you to the free by default. So basically, you will be getting an high definition content without compromising on the content. You can get it if you go for this IPTV. Whereas if you use a unicast service, there is a possibility that there may be congestion. Then your content will not be always a high definition. Even now we are getting a 4K channels, so those are possible with this multicast service.
Okay, sir. Thank you.
So cost-wise, for a service provider, it will be less or little only, because because the backend servers, everything will be already equipped with all this handling of this multicast. So effectively, the cost will be less. Only thing is when they have to run this head end and they have to have those channels lined up. So those things they have to put an initial cost. So when they start, if they are starting an IPTV service, the only thing they need is they put this head end and then getting those services from all the broadcasters, content providers. That is the initial cost. When they set up it, then it will be more of less for running those services. Service running cost will be very less for them.
Okay, sir. Thank you.
Thank you so much for your detailed explanation, sir. Any other queries from participants?
Good morning, sir. What is PIM protocol expansion, sir? PIM, IPTV, PIM protocol will be used in Soningala, sir.
Protocol independent multicast.
Okay, sir. Thank you, sir. Thank you.
It's an IETF standard which is used between the backbone routers to exchange the multicast routing information. You know, right? This multicast is dynamic. Say, for example, if there is a channel where nobody is watching, then I need to query or request that channel from the head end, right? To do that, this PIM protocol will be helping for the backbone routers to exchange that information. So dynamically, it will be exchanged, and then based on the need, the routing tables will be formed. So this protocol is responsible for that.
Okay, thank you, sir. Thank you.
Thank you.
Sir, it is protocol independent multicast, right, sir?
Sorry?
PIM is protocol independent.
Yeah, it's protocol independent multicast. So it is basically what multicast application you are using, it is independent of that. Basically, it's just saying I am exchanging the multicast routing table. It can be any use. I'm not to a specific use, but I'm exchanging the general multicast routing information. That is the meaning of that protocol independent. It is not independent of anything. Basically, it can be used for other services also in future.
Okay, sir. Sir, actually, though we say multicast is very efficient compared to unicast, may we know the reason why it is not being widely used by social media? Like most of the internet things and Netflix and YouTubes, they're not using multicast, right?
That is because your social medias and all server based. They are all not from the service providers, right? So they are independent of your network. So basically your users can be anywhere in the network, like Facebook or these days user will be anywhere. YouTube, even YouTube channel user will be across the world. That
Okay.
is not tied to a particular user. So if we have to do that, then this multicast will be extended to whole network. Okay, that may not be agreeable by all the service providers. Okay, so though that's the reason the service provider generally won't allow multicast data to be going through their network. They will allow multicast only when they need it. The service provider needs the multicast, then they will allow it, because by default all the backbone routers will be blocked for multicast, because multicast needs a replication, right? So the server has to do the replication activities. So but this social media and those things are independent of the services. It will be across the world, so they use these unicast services to handle their video services. That's why they have the load sharing servers to handle their large customer base.
Okay, sir. Thank you very much.
Thank you, sir, for your kind reply. Any other questions from the participants?
Professor Saranya, please proceed.
Okay. Okay. Sir, first, thank you so much for your wonderful presentation, sir.
Thank
You
you.
have shared us enough
லிங்க்
information about
ஷேர் பண்ண
multicast,
முடியுமா?
multicast
Share on.
basics, IP networking, and about IPTV
அந்த
and how
லிங்க்
it works in real-time applications.
ஃபீட்பேக் லிங்க்.
So once again, thank you, sir, for sharing your knowledge and spending your precious time.
Thank you.
Sandhu Gurusamy, sir.
Yeah,
Thank you
please.
so much, sir. It was a wonderful presentation. We have to thank you for accepting our invitation. And of course, you are very busy, too busy with all these projects and other things. And we are really very fortunate to have you at our faculty development program. Thank you for sharing your valuable time, also the wide knowledge to all our participants. Thank you so much, sir.
It's my pleasure. Thank you.
Okay. So thank you, ma'am. Thank you, sir.
Yeah.
As a token of gratitude, love, and remembrance, I take indeed a great privilege to present the memento award certificate to Mr. Sandal Gurusamy, Senior Technical Specialist, Nokia. So we are extremely happy to have you, sir. Thank you once again for accepting our invite and gracing our event, sir.
Okay. Thank you.
So I thank all the participants for your kind cooperation and for the interactive session. As you all know, our team will post feedback link in the chat box. It's already posted, I guess. So I kindly request you all to fill the feedback form and then let's break for the lunch.
Thank you.
And the next
Okay.
session will start around 12:20 p.m. Thank you all.
Yeah, thank you.
Kindly fill the feedback link and then leave the link. Thank you. Thank you all. Thank you, sir.
Thank you. Thank you, ma'am. I'm leaving.